do this. Okay, yeah, so welcome back to week 2 of Python. We'll do a little bit of review of the basic principles we did last time at the beginning, and then we will jump to the next stuff. So again, I was going to move my things to the side, got Replit open. So we'll just do a simple project. We just want to make a function. This is the problem on the side that accepts like a grade, like an 87 or like a 90 that you got on a test, and basically spits back out a value of like what, A, B, C, D that would be. So just like a little translation function. So again, anytime we do a function, we kind of have 2 steps. So we'll want to define the function to begin with, and that's just like the basic steps without any specific data input. And then we'll just call the function down below. So we can't use it until we make it, and we have to use it below the definition so that the machine can have read in the instructions and then use it. So anytime we want to make a custom function, we use def to say define. And again, we can kind of see the key vocab in Python this way, just putting this in my console. We can see def or define is one of the things. And now that we've had, one class, we've seen a couple of items on this. We know what elif and if and stuff is. False and true, that's Boolean values. So we know a couple of these, and we'll keep adding from this basic list of most of what you need in Python and the rest of the classes. So def, we can just name the function anything that I want. So it's going to call it this. And in the parentheses at the end that says it's a function, we just kind of name what we should expect. So we can kind of give it any name. So I'll just call it grade, and we'll just say when this function is called, we expect something to be given to us, and we'll just call that grade. Spit out the letter value of the inputted grade. So down below, this is called a doc string. I'll let you know the name. And again, we just use these triple quotes, which in this case just makes, it's kind of like a comment. It is technically a string, but it kind of doesn't do anything to the code. It's not like actually Python code. It's just a little comment just below the definition of the function. So anyone who's using the function, maybe even you, when you come back to it, you can quickly see exactly what this function does and stuff. And we'll just keep that simple. And then down below, we'll want to begin to write out the problem. So we'll kind of do this 2 ways. We'll do just a quick way, and then we'll kind of make it efficient and clean up the code a little bit. So in the problem, we have this list on the side, and we just want to kind of like go down the steps and do it that way. So we can begin by just like asking the question. We'll make a conditional statement with the if and in a conditional question. So we'll say if grade is above or equal to 90, then we can come down and say, maybe we'll do something like this. We'll say, if that's the case, then we'll come down and make this variable and give it the value of A. And then we can kind of keep going. Then we can keep going and say like if grade, and this is just kind of typing at this point, if it's above or equal to 80 this time, we can again do the same thing. So we'll say make a new variable and call it B. Well, hopefully we'll only hit one of these. So even though these have the same name, we should only hit one of these based on the logic that we set up. And then we'll just keep going, just a bit of typing. 70. Level root is equal to C. And then finally, I could just do an else at this point, but I could just say if grade is less than 70, so that'll kind of catch anything down to 0. I can assign that a D like this. And then all the way at the end, I should have hit one of them. I can use this, which basically ends my function and allows me to output something. And I can just output this because I should have hit one of these along the way based on what grade was. So that's my function. And then now we set it up. Now we can begin to use it and see if it functions, and then we'll see how we might clean it up just a little bit. So we'll come back down. we'll want to get the name of it. So we'll say, maybe we'll begin by doing something like this. We'll say like Matt got a 87, and then we can say output is going to be given by calling the function and giving it Matt, or Matt's grade if you want to call it that. Grade. And then we can just print output to see if it did what we want. And then as always, we can push play at the top, and that'll run this whole file and spit it out. And again, that's why I commented out all the stuff we did last week, just so I don't have a bunch of stuff in my console, taking up the space. Okay, so we got a C, we got an 87. Did I mess it up somehow? Oh yeah, it looks like, so it looks like we just had a little bug with the code. So I should have been saying less than or equal to 80. Actually, we had a double bug. So we can see the flaw in the logic. When I stick in 87, this becomes 87, and then I do the function top to bottom. So I didn't have above or equal to a 90, so I didn't go into this. But I was above this, so I did assign it a B. But then I also went into this because 87 is also above 70, just like it's above 80. So I went into that again, and it kind of said, put C in this. Even though we've already assigned it, I kind of wiped it out because I didn't have the logic set up the best way. So one way that we could fix this is to come in, and we kind of need to tighten up like the bounds of this. So we could say, in this same question, we can kind of do two questions at once. We could say if grade is above or equal to 80, and then we can use this new thing called and then just ask a second question. And then we'll say if it's also below 90, then we'll get a B. And then we can do the same thing down this way. And what this is doing is we can now ask two questions at once. And with and, let's see, and means both conditions must be true to pass and go into the if clause code. So now we can ask two questions. Instead of doing something like this, if we didn't do this, we might have something that looks like this. We might stack up questions like this instead. If we didn't know how to link two questions, we might say, begin by asking if it's above 80, but also ask secondly if it's below 90. And if we pass both of those, then we get to the B. But we can just link those two, and it's a little less sloppy if we just have something like this, just kind of ask two questions at once. So this is one way that we could set it up by having this new thing called and. And in addition to and, we also have this, which we won't use in this case, obviously. But when we link like an if sentence with two kind of questions, two conditions, what this does is we only need to pass one of them to go into the if clause. So we just need to pass one in this case, but if we switch back to and, then we need to pass both of them. And we can do this as many times as we want. We can link as many questions as we want. So if we want to check like three things at once and only go into the if block, if we pass all of them, we can just keep, doing that by linking that way. So that's one way that we could set it up, but we'll actually clean this up. Again, it's still a little text heavy, and we can actually do something that we did last class to have a little less code and have it be a little less confusing. So I'm just going to move this down and type above it so we can see both possible solutions at once, and then maybe we'll delete this one if we like the solution above it. So instead of that, so that's what we'll do now. So we'll use elif now. So we can say, beginning off the top, if grade is above or equal to a 90. And in this case, we'll do this step a second way too. So we'll say just give back A immediately. And then we'll come back down. Instead of saying if, we'll say if elif, grade is above or equal to an 80, we'll give back a B. Come back down again. Above or equal to 70, give back a C. And then we'll say else, give back a D. So we can see these two examples side by side, and we can see this one is a little less confusing, I think, and it has some like efficiency things that we like. So if we look at this one, we ask one question up at the top, and then if we pass that question, then we go inside its block. And in this case, we didn't like do an assignment of a variable that we hand back all the way at the end. We just immediately give back A. We don't even do anything, like this. We don't have to do this. Depending on the code that you have, you could do something like this, but in this case, we can just do it in one step. And if we pass that, we immediately end the function, so Python doesn't even see the rest of the code. But if we don't pass, then we go down to the next one. If it's above or equal to 80, then we give back a B. Same thing with C, and so on. And with the else, we didn't even need to have a couple extra lines of code. We could have just did else at the end. Okay, so we have a bug with this. Nicole, if you could type in or copy and paste the whole line that you have the bug in into the chat. And let me see if I can tell what's going on with it. And you can also look at the console traceback if you have a bug. So we could do this instead. And this both ends the function as soon as we ask this. And we also get the efficiency of if we use if and elif, we can only go into one of these. So if I like pass this one up above it, I can't go into this one even if I pass it. And that was the bug that we had down this way when I passed both above 80 and above 70 with that 87. Because I had two ifs, I could keep going on, and it kind of broke my logic. So with that, it looks like, Nicole, you just have a space in between the arrow symbol and the equal sign. That might, let me see if that causes the bug. Let me delete this. We'll keep the new code. Let's see if it actually runs. Yeah, so Nicole, you might have gotten the same thing that I have on my side, invalid syntax. So with this, you just need to come in and take away the space, and then you should be good. Like I said at the beginning, some things like the spacing doesn't affect anything. Like you could see in my console, the spacing between like pluses and minuses and basic math doesn't really affect anything. And even something like this, if I put a space between the name of a function and the parentheses, that's also fine. But yeah, I guess if you do something like this, then it needs those to be, side by side without the space in the middle. Okay. Yeah, so just a little bit of review. If you have any questions about, what we did last time or just this example, you can let me know. Yeah, so it looks like Nicole solved that. Or else we'll just move on to the next bit. Oops. Okay, so up until this point, we've done a lot of the basic stuff. So we know about just Python values. So we know about, and I can take this away, make some space. So we know about strings like this. We know about ints like this, my float. And we also know about Booleans. So this is basic values that we have, any type of text, which is inside quotes, any type of quantity, decimal, no decimal, technically two types, but kind of interchangeable. And then the last basic value type that we know is the Boolean type. So we know about those. We know also about the type function. So if I do something like that, I can check my type if I need to remind myself. So we know about the type function. And then we also added variables last time. So now we have the named things. Because like when we did stuff in the console, I could do math, but as soon as I got that result, that two, I couldn't like automatically use that in the next line of code. But now that we have variables, we can do math, update an object like that, and then keep using that again and again. So we have variables. We have functions. So we have a custom code block that, was something like a grade function when we might need to spit in, all of the students in a class to see what grade we got. We might need to use that. 24 times, or with the whole school, like 1,000 times, depending on how many assignments they have and stuff like that. So that's the use of a function. We can use it again and again and just kind of set some general instructions to a basic type of problem. And then we also added those conditional expressions that we just did, the Boolean values, which give the true and false and let you know if you go into the if, elif, and else clauses. So that's all that we did last time, basically. And now we'll add on the next kind of big thing, which is big in all programming languages, and that's the need to have what we'll call loops in coding. So I think last time, one of the examples we had was just like buying drinks, and we checked if someone had enough money to buy a drink. And if they did, we used like if to subtract money from the wallet and do that. But now the question is, what do we have multiple people that want to drink? How can we use that bit of code again and again? Well, if we have a function, we can use that function again and again. But if we have like 100 people out to dine, how do we call the function again and again without doing something like this? If we had a function called buy drink, how can we call it 100 times without, like copying and pasting it a whole bunch? How can we do that? So that's when loops come in handy. So let's set up this example, and then we'll add loops to fix it. So we'll have a wallet with $100 in it. We'll have the cost of a drink be $8.75. So say that's the cost. That's the available money that we have. So we have all the data up at the top. Just below that, we have the functions that we want to define. And then at the bottom of the page, we'll actually like run the code once we've, defined things. So we'll make a function called ask, and we'll basically see if we want to buy a drink. That's what we'll do in this function. And then we'll basically, we use that input function that we found out about last time. Would you like to buy a drink? And we can see when I push play, nothing happened, and that's because I didn't call my function yet. So I will call it down below just so we can test it. So would we like to buy a drink? And now we can put anything into this. We might, expect we'll get yeses and nos. So we tested that, and now let's come back. And this is when we'll get into using text, which we'll deal with, which will begin at the end of the class if we have time, and next class, and in the final class as well. But now we can just use something like this. We know about the double equal sign. That's basically asking if answer is exactly the following value. And we can just do that with text, actually, just so we can do that with quantities. So we could say if answer equals yes, then maybe we'll say wallet is going to be updated to be the previous money in the wallet minus the drink. So we update that, update money. And then we'll just put a print statement down below. And let's actually print wallet as well, just to see what's going on with that. And let's see what happens when we run it. So we want to buy a drink. Let's say yes. And we can see nothing happened. We didn't go into this. So let's try again. Yes. And we can see this time we got a bug. And we can see we have something new. We have a local variable wallet referenced ahead of assignment. And this is something that we kind of skipped when we began functions. And that's the distinction that variables set up inside a function kind of act by themselves. The function is like a closed off box of its own stuff. And this is a variable kind of, we can think of it as like a globally accessible value. So global variables, which we can technically use any place. And then we also have data inside of a function itself, which is something else. But what we need to do just to use this kind of global variable inside of a function is just do something like this, we just need to say we have wallet. It's up at the top of the page. And we just put the global in front of it to say we wanted to use that global variable inside this like local space. That's the function. So we'll set that up. That's just something we need to do. Able to use global variable inside a function. And let's see if we can do it now. So we'll say yes. And yeah, it looks like we did it. So we passed the check. Let's try it one last time. So I'll say yes. And then we can see obviously nothing happens. And that's because with text, we have to have like the exact match. So I put the exclamation point at the end so it didn't pass. And the same thing even happens if I just have a capital yes instead of, all small caps yes. So when we get into strings, we'll see how to kind of neatly handle this. But at the moment, we might just do something like this. We'll say, you can say yes. You can say yes, all caps. You can also say yes with just the Y capitalized. So when it comes to text, we have to have an exact match of some kind. So we'll just put up these multiple checks. And as long as we pass one of them, we'll get inside the function. That's how we can kind of handle, inconsistent data. We'll check that again. Now we can say yes. And then we get inside. Okay, so we have the function setup that we wanted to use. But now we can see, depending on how many guests that we have, we'll say guests, we'll say we have like 5 guests. If we only have 5, we could do something like this, but say we don't always know exactly how many guests that we need and we don't want to update the code all the time. What if we have, 50 guests? We can't, do this that many times. That obviously doesn't make sense. So let's go ahead and see how to set up a loop and what it is. So a loop is a basic thing that basically lets you repeat some code or some lines of code as many times as you want. So this is what it looks like. It's kind of like an if block. Instead of saying if condition, you say while condition. And then we indent, just like we do an if block. And then what happens is when we do all the code inside the if block, all the indented lines, when we get down to the bottom, we'll go back up to the top. So we'll go to the top line of the code, and we'll keep doing it top to bottom, as long as this condition remains true. So obviously, when we do this, if it keeps running top to bottom, this condition is probably going to change based on what's going on inside that looping code. So let's set up an example, and then it'll probably make sense if it doesn't quite yet. So let me move this down, and we'll do a little while block. So in this example, we just want to, we'll just count to 10, because again, it's counting to 10 is kind of something that's doing the same thing again and again. And we can use a loop to do that. So it's going to set up a count. I'm going to say 10. That's because we want to count to 10. So that's my data in my Python file. Let's set up my loop. So I'm going to say while, and that says it's a while loop. And then I need some condition, just like you would an if block. So I'll come in and say while count is above or equal to 0, we'll keep going. And actually, we'll say we want to count down to 10 in this case, so we can switch it and count up to 10 if we wanted. So while count, which is now set to 10, while it's above or equal to 0, we'll just keep going and keep doing the following code that we have inside the block. And now what we can do is we can say, well, one, we can think about it logically. If we can say just print, and then we can say count. And obviously on loop 1, that's going to be 10. But on loop 2 and so on, we want it to go down, like this, obviously. So once we say 10, the next step that we need to do would be to update count. So we'll come and say count, and we'll want to set that equal to count -1. And then let's go ahead and print that and see what it does. So we can see we got it 10, 9, 8, 7, 6, 5, 4, 3, 2, 1, 0, and we can see what it's doing. So when we come into this, count is now equal to 10. So we do go inside the while block because count is equal to true at this case. So we'll go ahead and print count as it is, which is 10. And then we'll say take count, which is 10 minus 1. So now count is equal to 9. Then we'll come back up and say 9 is still above or equal to 0. So we'll just keep doing the same thing. We'll say 9, and then we'll say 9 minus 1 is equal 8. So now it's 8, and then we'll keep going on and on. So that's the basics of a while loop. And the key thing is, well, two key things. One, any code that we have indented inside of it just keeps going top to bottom as long as we want. And then the second thing we need to handle is just checking that at some point this condition will eventually come to be false, and then we'll exit the loop. So eventually we want to quit it. If we did something like this, we've neglected to decrement count, and we just printed 10. When I push play, you can see it's just infinitely printing 10 because I haven't logically told it to change. So 10 is always above or equal to 0. So I'm just always running this code, you know, a couple million times by now. Oops. Oops, I closed my console. Hang on one second while I get this back. Okay, so we'll pause that, and then we'll take this and put it back in. And the next time we play that, this would logically stop, and we could exit. And if we wanted to, we could just change this to be the opposite. If we want to count up to 10, we could do something like we could say begin at 0. Oops. And then we could do something like this. While begin or beginning is less than or equal to, and we'll say this, we'll call this end in this case. So while this less than or equal to end, which is 10, we'll say begin. Maybe we could call that step or count. And then we'll want to update this as well. Like that. So now we did the opposite. So we begin with 0. As long as 0 is less than or equal to 10, we'll say 0, 1, 2, 3, and then we'll just add on 1 each time. So in Python, we can easily, you know, loop anything that we want, but you can see, unlike a lot of things, you know, in life and technology, when it comes to coding, you really have to kind of code all the logic. So even something like basic counting to 10, you kind of have to code in all the instructions exactly. We kind of have to teach Python how to count. We can't just tell Python count to 10. We need to kind of set up the math of how to do it. Okay. Let's do a second example, kind of the same thing, but we'll just do it again. So in this case, let's add up all the numbers between 0 and, you know, something. We'll say maybe, you know, 100, and that'll kind of be just a second example. So in this case, let's do something. Let's set up a function that does it, and then we'll have a loop inside of the function. So we'll call it total, but we want to sum up everything, and we'll accept something called n, and that'll be like 100. We'll do this, add up. Just define what's going on. And then now that we've made the definition of the function, we can kind of do the same thing that we did by setting up a while loop. So we'll say while, you know, some condition. And what we'll want to do is kind of the same thing we did with counting up. We'll want to begin at 1, or we could begin at 0, but we'll just begin at 1 since adding 0 to anything doesn't do anything. So we'll begin at 1. And then we'll also want to keep track of a total. So all these data points that we need to keep track of, we need to make. So we'll begin at 1, and we'll slowly make this 2, then 3, and then all the way to n. So that one we would be modifying. And then each time we go to 1, 2, 3, we'll want to add that to the total so we can get that like sum of the whole thing. So that's my data up at the top. And then down below, I can actually begin to use it. So we'll say while, my beginning is less than or equal to n, we'll keep doing the following again and again until this statement becomes false. So we'll say, we'll add total. We'll add the count to the total. So we'll say 1 + 2 + 3, and then we'll just update total. So that'll be that line. And then we'll also need to do this. We'll just need to increment each time. So this will be the 1, then the 2, then the 3. One thing I'm going to show you is that this is kind of the full way to write out this line. But most of the time you won't see this in most Python code. So what we can actually do is lines like this. And these mean the same thing. So this means total is equal to total plus this value. And this is the same thing. This is equal to its old value a second ago plus 1. So these do the same thing. This little abbreviation is kind of taking the place of this block of code. And we could do this with any of the math symbols. So we could say x, minus equal 1. So that would be x is equal to the old x minus 1. You can do that with multiplication and division as well. If you want to, you can still write this so you can kind of see what's going on, but you'll most likely always see this kind of writing when you see Python out in the wild. So I'll begin to use this from now on. Okay, and now we have this setup that should handle everything. And now we'll still be inside the function. So you can see I've outdented from the while loop. So now I'm at the same level as the while loop. So I won't get to this line until I finish looping, but I'm still inside the function because I'm still indented once. So I'm still inside definition of total. So that can get take a little bit to get used to, indenting a couple times and seeing, how you match up and what I'm inside still. So we'll just say, we'll go ahead and print out the total once we loop all the times that we need to. And then we can also give back total when we call the function as well. So let's come down and let's just call the total function, and we can just give it 100. And let's see what that does. So 5050, that makes sense. We can test it with like a 5, something that we can, do mentally to see that that's good. Yep, so 15. So that's good. And then we can also see if we wanted to, we could accept it on the outside if we want, depending on how, we needed the code to go. But I've just printed inside the total function, but then I've also handed it back so I can kind of save that piece of data and use it down below. But in this case, we don't really, need this line. So we could take this out if we wanted to. One thing I'll just kind of add in, just so you know about it. Anytime we set up an expected input in a function, so like when I say I'm expecting something called n, that can be anything. So instead of a 5, I could give it like the text hello. And you can see when I do that, obviously the code breaks because I'm, as a human, I'm expecting it to be some quantity, but the machine doesn't know what n is supposed to be. And when I begin to use n, which is just hello, and I begin to want to add to it, mathematically, we can see we break the function. So that's something we'll need to add skills to. I don't think at the end of this class, but you'll be able to catch bugs and tell Python what kind of data to expect. But one thing that we can do right now is instead of saying what type we expect, we can assign a default. So if I do something like this, and then I'll run it like this. So I'll give 5. And it's still saying n is equal to 5 when I begin this function. But now that I've given a default, I can just call the function, and if I don't supply anything, it'll just use the default by itself, by default. So you can do that as well. But like we mentioned last time, if I'm expecting something in the definition of a function and I don't supply it, that'll break the code, because Python knows, definitionally you need something. So if you don't supply it, it's just going to stop and tell you you need to supply it. Okay. Okay, so we'll go back to the buying drinks example that we had a little bit ago, and now add in using a while loop to set that up. So let's see, we have the wallet, we have the cost of a drink, we have the function, which is basically going to ask, would you like to buy a drink? We set it up to accept kind of any type of yes. And if we get a yes, we'll access the global wallet, then we can update it, and then we'll just print, have drink and the amount of money that we had. Down below, we have set guests to 50. But now we can do this with a while loop instead. So we'll kind of tidy this up a little bit. We're at add to it, I should say. So we'll say I'm just going to call this X. So this will be one guest. Actually, I'll call it G because that kind of makes sense. So I'll say G, one guest at a time. And then this is kind of my total count of all guests, because I'll want to keep track of 50, but I'll kind of want to go one by one, just like we've been doing with the counting with the while loop. So while G is less than or equal to guests, we'll keep doing the same thing again and again. And all I have to do at this point is just put the ask function call once, and then hopefully this will run 50 times, or maybe we'll update this to 3 times so we can actually see it in action. So let's push play. We can see what Python is doing. It kind of studies the file top to bottom. It kind of memorizes the data that we have. It memorizes the steps of this function, but doesn't do anything yet. And then some new data as well. And then finally, it gets to something that it actually needs to do. So it begins a loop, and then it begins to actually use the function that it memorized up above. So we'll say yes. We subtracted the money, we printed it out. We'll say yes again, and then you can see it's still going. So let's see what we did. Did I make a mistake? So we'll analyze the code. So we see we have guess is equal to 3, G is equal to 1. So we say, well, 1 is less than or equal to 3. And then that should be 2 less than or equal to 3. We did an obvious thing. We did not increment G. So that's the mistake that we made. We did one guest at a time, but the way that we did it, we basically kept asking the same guest, or guest 1 of 3, the same question again and again. So we need this line actually change guests. And again, we could do this, but we could also just do G plus equals 1, which is basically update G to add on 1 to its value. So let's push play again. So now we can say yes, 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 yes. And then you can see Python finish the function, and now it's back to the console mode. We'll play that one last time. We'll say yes, we'll say no this time. And you can see we didn't code in anything to say anything when we said no, we just kind of skipped to the next one. No, but we can see it still passes and it's counting correctly. So we could add in something if we want. We could just say an else and print something like this. And the else would be a good thing to have in this case, because we can imagine what people might input. It again could be no, it could be little no, it could be capitalized no, it could be something like this. They could type in, no, thank you. So again, we'll see when we get to strings how to kind of handle any of these at once and just catch them with one simple line. But right now we don't want to do all this, so we can just use the logical definition of else to just say, we'll catch anything that's not a yes and say you don't get a drink. One thing that we didn't do in this one is we didn't catch is what happens if we don't have enough money. So we'll go down to $10 and a drink costs $8.75. So we'll say, would you like a drink? Yes. And then you can see we can basically go negative. So if we wanted to, we could keep cleaning this up and we can kind of add on to this if we want. So at this point, people would say, yes, they want a drink. But then we could add a second question on to say, if wallet is above or equal to drink, then we can go ahead and do all this. So we'll indent that. And we can say else, if they wanted a drink, but they can't buy it, we can put something, you can't buy this. So you can see we can begin to stack all these, and it gets kind of a bit messy how nested it is, but it should handle anything that we throw at it now. Let's see what we did. Oh, let's just move this to the top. So what happened with this bug is I had my global wallet down this way, but I just added this line above it. So I just need to move this to say I'm allowed to use wallet inside the function. Let me just put it all the way up at the top of the function. So now when I get inside ask, I'm kind of inside the function as its own little entity, but I'm just saying I'm going to allow myself to use this kind of global object that I have. So that's that should fix it. So we'll say yes. Let's say yes again, and it says you can't buy this, and we'll say yes again. Does the same thing, and then it closes the function nicely. So that should handle all of that. And you can see as you begin to think about how people might respond to the question, what kind of situations you might run into. People say yes, but you don't have enough money. You begin to stack all these questions, and it can get a bit complicated. But it's still just using the same simple tools again and again. And now that we have the while loop, we can just change this to 300 guess if we want, and it'll do the same thing as many times as we want. Okay. Okay, so in the handout, which is in the email if you don't have it open now, is a couple like practice problems. I'm gonna skip them now, and if we have time at the end of the class, we'll go back and do them as practice. But again, it's just practicing all that we've done, and it'll just take a minute, new types of problems. So I'm gonna skip past those. I have the solution in this, but we'll get to the new content and then come back to it if we have time. And we'll also take a look at them at the beginning of next class. If you have any questions, we can begin with looking at them. Okay. So let me come into my code. I'm just going to take away this block. I'll leave my function definition in because that won't do anything in the console, but I'm just going to move that down this way. Okay. So up until now, we've seen the basic data types that we reviewed a couple minutes ago. We have both types of like math type data, ints, which is the whole amounts, -5, +1,000. We have the float, which is anything that's a decimal, 2.2, -5.5, even 1.0 is technically a float. Though again, we don't have any issues mixing and matching them, so it's no issues with that. We've seen strings, just printing out messages, and the last basic data type is the Boolean, which is true and false. And that's the one that lets us ask all those handy questions and do specific lines of the code based on conditions. So that actually is basically all the simple data types. And then we'll move on to next is what's called collections or sometimes sequences. And that's basically data buckets or new types of data that can just inside of them hold all of these basic data types. And the one that we'll begin with is just called a list. And that kind of makes sense because it's just a list of multiple pieces of data. So we'll go ahead and come to my replit, and we'll begin by seeing how do you make one, how do you use it, what does it look like, how to do stuff to it. So list container multiple data variables. So I'm just going to begin by doing something like this. Let's do an example of each piece of data. Let's call that false. And then let's come down and make the new thing, which is just a list. So I have my list, just like setting up all these data points. This is the same thing. You give the new object a name. So it's going to be just called my list. We set up an equal sign. And then on the right-hand side, we actually put the values that'll be inside of it. A list just by itself looks like this. It's the boxy brackets. So if I just want a blank, like an empty list, I can just do this. So I'm going to come in and actually print it out so we can see what it looks like. So I can print my list. And you can see it just kind of looks like itself on the console. And if I check it with type, it also looks like it'll just say it's a list. But what we can also do is set up a list, obviously, most of the time with existing data that we have. So we could want to have all of this data in one kind of bucket. So we could say my list is equal to A, and then in between each piece of data, we'll put a comma, and then we can just list as many pieces of data as we want. We don't have any real limit to how many pieces of data. We can mix and match all the pieces of data. So you can see I have ints and floats and strings and booleans, and I can all put them in the same list. So that's fine. I can also just put straight values in. So I don't need to make an object and then put its variable name in. I can just put a string in. I can just put a float in and a false. And then one last thing that lists can do in all types of collections is that inside of them, they can have kind of sub lists. So we can have a list within a list. And this is just kind of like if you had a bullet point list and then one of the bullet points had sub bullet points attached to that one specifically. This is what this kind of is. It's just kind of a shopping list of things. And then, this last list could be, all the things that I would find in the cold aisle. So that's why I might make it a sub list like this. It really depends on and why you need the list. But we can put kind of anything and everything inside of a list if we want. We'll go ahead and print that again to see what it looks like now. So you can see, yeah, it looks exactly like it does as we typed it out. Once we have a list, obviously we'll want to do things with it. We won't just want to type all this out manually and then not be able to do anything to it. So just like we can set up, B equals 1 and then B plus equals 10 to update that to 11, we can update a list once we've made it. So to update a list or add a new item, we can just put the simple line my list, and then it's called dot notation when we take an object and then put dot append or dot some name at the end of it. And basically this is going to say append what's inside this to the object my list. So we'll go ahead and say we'll append a 1 to it. Let's see if that does it. So we can see in the beginning, my initial print, I had this, and it ended with that sublist. But when I appended 1 to it, I have my whole thing. And then it automatically adds to the end of it as the new last item, my updated thing. So that's how I can add one thing to the end of it. Once you get into high-end Python, you can add things kind of in the middle of the list, at the beginning of the list if you want, kind of any place you want. But we'll just deal with the basics at this point. Remove last item will be the next thing that we do. So instead of dot append, this one is called pop. And so we can just say, we don't even need to put anything inside of pop. It's just going to remove that last item. So let's see what that looks like. So you can see we had my list ended with that sub shopping list. Then we appended 1 to it. So we added 1 as the new last item. And then we just use dot pop, and that always just takes off the last item in the list. So the final print statement lacks the one. It took that off instead and removed it. One thing about dot pop is we can just do it like this, and it basically just deletes the last item. But if we want, we can kind of take it out of the list and kind of take it as a new data point to use someplace else if we want. So we could do something like this, where we can set mylist.pop equal to something called element. And then we can see we have my list without the one, but then I have the one as just element at the end. So I printed them kind of side by side, but now the one is its own thing and the list is back to the list without the one in it. So we can make a list, we can add something onto the end of it, and we can also remove things off the end. And like I said, once you get past the basics of Python, you can remove any specific item in a list. You can remove from the beginning of a list. You can add in the middle of a list. But we'll just do these basic methods at this point. So that's the basics of lists. And you can see why we began to talk about lists, because now that we have a loop, we can begin to do, we can set up a list with a whole bunch of data and then set up a loop, a while loop, to do a whole bunch of instructions to all the data points in a list instead of just one thing at a time. So like with the grade function that we had, we only did one grade at a time, but now we can make a list of a bunch of grades, and then we would process them all at once. Okay, so I'm going to take out that. So that's all the stuff about just making lists. And now let's go ahead and talk about the second and final type of loop. Loops all do the same thing. They do the indented code again and again, just looping top to bottom. But this second the second type of loop just does it in a slightly different way. So what we'll begin with is just setting up a list of grades. So now we can do a whole bunch at once instead of just one grade at a time. So I can just put in anything that I want. So that's my list. Just like the spacing between things, you don't have to have the space between the commas, but just stick to one thing and make it consistent. And then also you'll notice I put a comma at the end with nothing behind it. You don't have to do that. You can just end it like this, but it's also fine if you just put a comma at the end of it too. You'll see that out in the wild a lot. So that's why I do it, so you'll know what it is. So we set up grades. And now the second type of loop we have is, instead of like kind of saying and manually counting up and then stopping when we finish a condition, this second type of loop basically takes a collection of multiple data points, the 100, the 90, the 98.5, and loops as many items as we have in that collection. So this is what it looks like. Let me set it up. We'll see what it does, and then I'll kind of explain it bit by bit. So we can see what happened. I got each of these one by one and printed them out one at a time. So what this is doing is we can kind of look right to left. So we begin with grades and we want to kind of process or loop that. So we say grades. This one I just made up the name of. I could call that anything I want. So I called it grade to make it logical. And basically what it's saying is, for each grade in grades, or for each something I'll call X in grades, do the following code one at a time, apply to each of those items. So this type of loop takes a specific list or collection and processes it exactly that many times. We don't have to like manually count up and then say, like a while loop, when is something is true and false to cut the loop. This one just does it front to back, and then it stops by itself. One thing that we'll add in now is just a new little help function that you can use now and then. This is the length function, but it basically just means length. And we could see it came out to 6 when we printed it. And in this case, length just means how many elements or how many items in some collection, in some sequence. So I have 6 grades in this. So if I do length of grades, that's going to give me 6. Okay. So now let's take a look at just this type of loop by itself. So like just like a while loop, we need to pay attention to a couple things. We need to manually ask the question, while what condition is true, we'll keep doing the following. And with a while loop, we need to manually check that we always flip that condition to false eventually so we can stop. We also have some specifics about this type of loop to do different things and just different ways that it behaves. So let me comment this out so we can still see it, but it's just not in the way. And then we'll see in this case how we can not just loop the amount of times of an element in a list, how long a list is, loop that many times. We can also see just how to loop, 100 times if we want, kind of like we could with the while loop when we could set it up and count to 100. We can do the kind of same thing with this type of loop in a second way of using it. So instead of making a list of 100 things, how can we just loop 100 times if we don't have some list? This is a new function that we have. And this function, what it basically does is it's kind of like the manual while loops that we've been setting up. It kind of manually counts from something to something. And the step is like how much it counts up by. So most of the time, you'll count up by 1. So if this is 1 and this is 10, and this is 1 as well, you would begin at 1, 2, 3, get to 10, and then you would loop 10 times using this. So my range function is going to make basically a list of 10 things. So if I have something like this, begin at 1, go until 10, and then step or increment by 1, that's basically kind of going to make something like this we can think of. It's not quite making a list, but in a way it is. That essentially lets us loop 10 times if we want. So we'll set up an example and kind of see how it goes, and then it should make sense if it doesn't yet. So we set it up the same way for something in something. So we'll just call it n. We can call it anything. And then now we'll use the range function in place of some collection of a set amount of objects. So this is grades with 6 items. What if we just want to count to 6 without having a collection of 6 items? Well, we can do it this way. We'll say begin at 1, count up to 6, and then step by 1. And then let's print out, in this case, n to see what's going on and how it changes each time that we run this. So we can see it kind of did what we want, not fully. So it got 1 to 5, so we'll address that in a second, but it looks like it's doing basically, what we explained a second ago. So a couple things we need to add on, and this is in the notes, is we have these inputs. Some of them have defaults, just like we talked about a second ago. Anytime you set up a function, 3 equals 100. Anytime you set up a function, you can set a default. And if you set a default, you don't need to supply anything. So you could just leave it blank. So we can use that kind of thing the same way with the range function. So let me do a second example. So the optional things I have highlighted, and the only thing that we need to supply is actually stop. So stop is the only mandated thing. This has a default of 0, actually. And step has a default of 1. So if I assume those defaults and just want to count up to 10, I can just say this. And that's going to be the same thing as this, beginning at 0, counting up to 10, which we supplied, and stepping by 1. We just used the defaults and didn't have to put them in. So if we come this way, yeah, we can see we begin at 0. And then again, we get all the way to 9, but we wanted to count to 10. And that's something else we need to pick up. Not only do we have defaults with these two, but we have to talk about like what's non-exclusive. So this one, stop is non-exclusive. So what that basically means, if my stop is equal to 10, it's going to stop ahead of 10 at 9. So we can think of the stop as like a stop sign, and you want to stop ahead of the stop sign. So if I want to count to 10, I actually need to say range of 11, and then I'll stop at 10 because I don't want to get to 11. So it's a little tricky to get used to, but it's something that you'll see in all types of coding, not just Python. It's kind of like non-exclusive and when you need to stop and kind of like being offset by 1, going to 11 to actually count to 10. So you'll see that a lot. But you can see now that we did this, we got from 0 to 10 just like we wanted, but we just had to put in 11 instead to actually do that. Let me comment these out, and then we'll see a couple additional things this type of loop can do. So if we want to count down, we can kind of set that up just using the same thing that we have up above. So we'll say for number in range, and we'll say we want to count from like 10 to 0. We want to do a countdown in this case. We can just set that up logically. So we want to begin at 10. So we'll just put it in 10. We want to stop at 0. Let's try that. And then the key thing we have to do is, what do we want to step by? What do we add each time to get from 10 to 0? And in this case, we can't use the default because that would be 1. So we just need to specify we want to go down by 1 each time, and then we'll be allowed to use this to go from 10 all the way to 0. Oops. So set that up and test it out. And we'll see that again, we made the same mistake. I said I wanted to count from 10 to 0. So stop is non-inclusive, I should have been saying, non-inclusive. So if I want to count all the way to 0, I need to kind of go to -1 as my stop sign, stop just ahead of it, and actually go to 0 itself. Yeah, non-exclusive makes sense. Okay, so 10 to 0 like that. And then one last cool thing that we can do, kind of mixing and matching how we use these inputs to the range function, is we can do something like this. Begin at 0. Let's count up to 100. So let's go to 101 and stop at it. And then we can step by 5 if we want. And that'll basically count up by 5. So if we play this, beginning at this point, 0, 5, 10, 15, all the way to 100. And then we don't even, and then you can see if we did something like go to 103, typically that would take us to 102. But since we count up by 5s, it actually doesn't even apply because 102 is not like divisible by 5. So it doesn't even really affect anything. But, we'll leave that as it should be. Okay. See a question? Oh, yep. Okay. So let's do, and then just to compare these two types of loops, we'll come back to while loop and set up the same type of problem with the while loop and just kind of see the difference between them side by side. So let's again do that problem, add up everything between like 0 and 100. So the problem is add up all numbers between 0 to 100. And we'll do it with both types of loops to kind of see the difference between them and just how you have to set it up. So in this one, we'll set up a little comment like this. So we want to do this. Stop is mandated, and then step. We'll comment that out so it doesn't affect anything. So we'll just begin at 0. We want to go to 101, and we'll just, the default is 1, so we don't have to type this, though you can if we want. So I'll just take that away. And we'll say, 1, we need a total to set up. So we want to begin with some total plus equals the number that we count to. And then let's print total at the end. And let's see what this does. We'll see if we did any bugs. So in this case, we wanted to count up and add everything 1 to 100. We just got 100 at the end. And if you take a second to look at it, we didn't get a bug. Python didn't crash when we did this, but it's obviously not doing exactly what we wanted. And let me show, it might be obvious, but let me show you kind of a visualization of this code to kind of see what's happening and what the kind of logical mistake was. So this is a neat site that you can go to that's basically going to visualize how the code is running, and we can see it step by step, one line of code at a time. So it's going to copy my code into this, and let's see what it's doing. So again, it's going to go line by line. So this little arrow is kind of pointing to what Python is looking at that moment. And then they'll click next to go line of code by line of code like that. So you can see we go into the loop. We can see the data objects that we have on the side. So my variable n is on the side. It begins at 0. That makes sense. I get to this line inside. And I kind of say, okay, let me save some object called total. It's equal to 0 now. Then next, we'll add the n to the total. Okay, so that we didn't add anything because it was 0. We come back up to the top of the loop and we update the n. So now this is equal to 1. But you can see the issue as I begin to keep clicking. I keep counting up, 1, 2, 3, 4, 5. But because I initialize total inside the loop, each time I loop the code and go back up to the top, I'm basically deleting total and setting it back equal to 0 each time. So that's why in the end, if I get to my last step, it's basically just the last n that I had. It's not adding them all up at once. So if we come back, we just need to make a simple fix. Let's initialize this above the loop so we don't keep deleting it each loop that we do. And then we should have it good to go. Push play. And then you can see, yeah, we got that 50-50 that it actually is. So that's with the one type of loop. And now let's just see the second type of loop. Again, just to kind of see it and get some practice setting these things up. So with a while loop, you tend to need to kind of manually set up a bunch of things to kind of manually keep track of the count. So with this one, let's go ahead and say, and I'm going to call it total 2 in my code, just because I already have total up above, so I don't want them to get messed up in any way. So it's like total 2 is equal to 0. We know with the while loop, we have some condition that we need to keep asking. So we might say while counting is less than or equal to and we'll call it, max. So let's go back and say max. We want to count up to 100. So that's what max will be. And then we also need to set up counting. We'll set that equal to 0. And that's the thing that will change each time as we increment. So you can see, even as we begin, we have to manually set up a bunch of things with the while loop that we didn't quite have to with this type of loop. And that's just a difference. Obviously, given that, in a lot of cases, you would want to use this loop. But a lot of the times you'll still want to use the while loop because it can do some things that this one can't. But we'll just keep going. So we'll say while counting is less than the max, counting is 0, then 1, then 2. So we'll come in and say total 2 plus equal, when I'm counting. And then I also just need to say, I'm going to keep adding to what I called counting to get to 1, to 2, to 3, all the way to 100. And then once I get to actually 101, then 101 is not less than or equal to 100. So then I just skip this on the last one, and then I can just print out total 2. Let's just check that. And yeah, you can see we got the same thing. A couple extra lines of code, a couple extra things that we needed to keep track of. Obviously, in this case, this is the one that we would want to stick with. But at this time in studying Python, it's good to kind of know how to do things both ways. So when you get to some unknown problem, you can kind of see which one would fit best. Okay, so let's go back to that grading problem. Let me go back down and find it. Actually, instead of this, we'll do an averaging problem. So I'm going to come back up, delete this, and let's make a new function called average. And I'm going to expect something called grades. And let's just kind of define what's going on. Function expects a list of ints/floats to get an average. So that's what we'll do in this one. And let's go ahead and set this up. So, finding the average, basic math, so we'll set up a total to add them all up. And then we need to divide by how many elements in the list. So in this case, you would add these all up, divide by 6, and that'll give you the average of that set. So we'll say we want to initialize a total. How will we find kind of automatically how many items in a list? Well, that'll be the len function, or the length function that I gave you a little bit ago. So we'll use that in just a second, but we'll go ahead and say, give me split up grades one element at a time. We'll call it grade. And then what am I going to do to each of those one at a time? Well, I'm going to add them to the total so I can add them all up. And well, that's actually all I need to do inside of the loop, just add them all up. And then once I have that grand total, I can make a new object called average. I'm going to set that equal to the total divided by, and now I can just do length of grades. And in this case, that'll be 6. Although the nice thing about this, instead of just putting 6, obviously, is that anytime I give some list of grades to this function, it could be 10 grades, it could be 1,000, it could be 2. It's going to automatically calculate the actual length. So that's why I don't want to just put 6, because then that would make this function only suitable to lists of 6. We can set up this so it's applicable to any type of problem that we give it. So we don't want to type in actual values usually in the definition of a function. We want to keep it like as dynamic and open as possible by doing things like this. So we'll give back that. And then let's just spit it back out at the end. And let's go ahead and call the function. So we have grades up above, so we don't need to make that again, but we'll just come in and say, call my average function, spit in that grades that I gave it, and I will accept on the outside something that I'll call A, and I'll just print that out. And I'll do something like this, just so we can see what's going on. One thing I don't know if I mentioned this, or maybe I kind of skipped past it, but one thing that we'll notice is sometimes these things have the same name. So I input something called grades, and then I'm expecting something called grades. Those names don't need to match up. So I could call this, students, and obviously change this. But what basically happens is when you call a function, you take the actual object themselves, just the list of values, take it out of the box labeled students, and give it a new label, put it in the new box called grade. So the names don't need to match up on that side. And the names also don't need to match up at the end. I calculate my AVG, my average, inside the function. And what happens is when I output it, I basically, again, take it out of the box that I had just called AVG. I just have, probably a float in this case. And then I can put it in this new box that I call A on the outside of the function. So just to clarify, these names don't need to match. It's totally fine that they don't, although often, it'll obviously make sense if they do anyway, but, they don't have to. So let's check that. We got an average like that. Let's just do 1 second check. So I'm just going to do this all in one line. We'll call an average function. I'm just going to put it inside a print function, so I don't need to split it into 2 lines like I did. And then just to do this all in one line, I'm not even going to set up an object like I did above. I'll just put the list straight inside the input to the function. And in this case, I'm just going to do something like this, just so I can check that my math comes out. It should be 100 if everybody got a 100. Give it a second. That might be my Wi-Fi connection. Let me comment that out, see if I did a bug. It's just connecting again. Okay, hang on 1 second. Okay, let's try it again. Okay, yeah, we got 100. That makes sense. Okay. Anytime you set up a new function, it's best to just test it a couple ways, see if you can break it in any way, so that you don't deploy a product, a website, a function, and have, a client find out it's broken. You want to test it as much as possible while making it. So you want to set it up to do what you want, but you want to test it to see if you can make it fail so it's as robust and clean as possible. Okay. So we have the basic function. We tested it once, but now let's do one last thing. So I'm going to take away the calls to the function. I'm going to keep my function definition. And in this case, I'm going to also change this and give a new data object. And in this case, I'm going to do something like this. So I'm going to say 90, 90, 90, 100, 90. And we'll do one last one, 80, 85, 90. And now what you can see I've done, it looks a little bit complicated, but I have a list. So you can see I have enclosed it in the boxy bracket. So I just have a list. And inside of a list, you can break it into new lines just so you can kind of see it. So that's totally fine. And then I just have 3 elements. So I have element 1, a sublist. We can think of that as one grade or one, maybe test or one class of grades. Element 2, and then we have element 3. So now we have a list of lists, and that's how we can use average to get all of them at once using all that we've, kind of studied up until this point. So we have all of these. Let's just kind of print this out. Let's kind of see it a little bit at a time. So let's print out grades just to see what it looks like. Yeah, so it looks like that. Let's jazz it up a little bit. Let's break it down as we know. And actually, instead of grade, let's call this maybe class. Actually, call it test. You'll see that when I type in class, it's highlighted blue instead of the black that it should be. And that's because, let me just show you. Class is one of the something in the Python vocab, so that's saved. Python calls something class, so you can't call it class. So we'll just call it test in grade. So we have one class, and they took a couple tests, and we want to get the average of all the tests. Print out test, and now you can see when we get that, we get each of them one at a time. So we can begin to see, even though it looks kind of complicated, we can break it down using a loop. And then once we break it down one at a time, we can set up the same thing that we did a second ago. So we'll call the average function on each test one at a time. I'll just, call that A in the moment. And then we can go ahead and do something like print out, A. Let me uncomment these. And then let's see if that does what we want. And yeah, you can see now we've taken the list of lists, gotten one list at a time called test, take one at a time, call the average function, call it A and print it out. And you can see we got that 90, 95, and 85. So now that we have loops, now that we have lists, we can do lots of computation to a whole bunch of data at once, combining these principles. So I could have, 1,000 lists inside of this one, and I could even have sub lists inside of that. I could break it down by, I could get the grades of the whole school at once if I wanted. So I could have a list called school. Inside of that, additional lists called, grade 5, grade 6, grade 7. Inside of that, lists called, class 109, class 110, and then continue breaking it down by, each test they take, each assignment they take. And then we'll just have to kind of stack the loops and the function calls that we do to kind of build that all up. And then one last thing we'll do, we just printed these out, but we actually know how to save multiple data. We have a list which can hold multiple data, and we know how to make lists. So let's actually save these data points instead of just printing them out. So I'm going to come back down. I'm going to make something called averages. I'm just going to initialize it as an empty list, and I'll put each average in as I get it. So I'll set this up, run my loop, go one test at a time. I'll still print it out, but what I will also do is use that append function to add in when I'm just calling A, that's kind of my throwaway name. And then I can save it. And then all the way at the end, I will print this out like that, and maybe add a string in front of it, average of the tests. And let's see if we did that just fine. And yeah, so now you can see we can process lots of data, and we can also save lots of data as well. So just by adding a list, now we can kind of do millions of things if we want, as long as we know how to do the steps in between that. But we can definitely handle the data itself now. Okay. Okay, any questions? Do we want to pause and do an example for see anything again? We'll do one last example of, loops and lists and things in a second. But if you have anything specific you want to see, we can do that. Okay, so we had lists within lists. Let's see the last thing that we'll look at within this section, which is we want to do a multiplication table in Python. So I'm just going to set up a basic multiplication table. You'll kind of see what I mean. And then we'll do the second step of the problem, which is to kind of make it complicated and see how we can do it in Python. So what I mean is we'll get like a 5, and we want to print out the multiplication table of that. So 5, 10, 15, all the way up to like 5 times 10. So we'll call it n, what we want at that given moment. We can use the range function to count from 1 to 10. So I'm going to go from 1. I want to get to 10, so I'm going to stop at 11. And again, I can say that I'm incrementing by 1, but that's the default, so I don't even need to put it. So you can see with this basic thing, I'm counting 1 to 10. And now I just need to combine that with the 5 to actually get the multiplication table itself. So instead of just printing out 1 to 10, let's print out n times 1 to 10. And then you can see we get a simple multiplication table. That's fine. That's nice and easy. And now the second thing we want to do is let's kind of, continue to jazz this up. Let's make this a function instead of just, kind of naked code floating in my Python file. I'm going to change this to be a Python so I can use it, as many times as I want. So we just change this to this. I can delete that. I can set a default. We'll say maybe 5. Call my function. Let's see if it does the same thing. Yeah, you can see that's fine. You can see I can beat out the default by supplying something instead. So I can give it a 2 instead. I can give it anything that I want. And now the second thing that we'll want to do to make this kind of a difficult problem, kind of see all that we can do in Python, is to ask how we can print out multiple multiplication tables at once. Say I want to print out the multiplication table of like 5, 6, and 7. How can I do that easily? I could do something like this. I said 5, 6, and 7, so let me go back up. I could do something like this. When I just call it multiple times. But again, this might look easy, but if we have to do something, a lot of times, this is a lot of manual typing that we would need to do if we didn't just have 3 items. So it's not the best way to do it. So let's see how we can change this a little bit to kind of not type so much manually. So I'm actually going to take this out again, and we'll just do this by itself. So I have this. By itself. Let's just clean out my console. Oops, we can put back n. Okay, so I have just this by itself. Again, we'll leave the function behind just to make it a little less complicated while we get the idea. So I have 5, but I also want to do 6 and 7 at the same time. So how can I do that kind of, intelligently without writing so much manual code. And that might look something like this. So we know how to get this. We also know how to get something like 5, 6, 7. So let's do that step by itself. We'll call this X in range. We want to begin at 5. We want to get to 7. So let's go to 8. And then we'll print X. So I'm doing this problem in 2 steps. I'm getting my 5, 6, 7 using code instead of doing a bunch of manual typing. So I got my 5, 6, 7. I also know how to get the multiplication tables once I have a 5, once I have a 6, once I have a 7. So that half of the problem is good. And now we just need to kind of combine these in the same bit of code so we can do this all automatically. So what we can do is we can just kind of actually combine these. So we can see I'm setting n equals 7, but up above, x is basically acting as my n, giving me my 5, 6, 7 instead of just coding it by itself. So instead of printing this out, what I can do is I can delete n equals 7, and I can just copy this, or I can move it up a little bit. And then let me indent this. And then what I can just do is something like this. And let's see what it looks like. And then I'll explain it because obviously I did a whole bunch just then. And I'm also just going to do this real quick. So it's not as. So we can actually see it in the console. Okay, so we can see what we got what we want. We did it kind of automatically. And let's go back to the code and see how we kind of combined a whole bunch of things in a new way. So to begin, we needed the kind of things that we needed to multiply by. So we needed 5, 6, 7. We set that problem up like this. So inside of this, we get 1 at a time each time we loop. 5, 6, 7, and we can change that to anything we want. If we want to get the multiplication tables of everything from 1 to 20, now we have that capability to just do it easily. So we got that n. And then what we did is we put a loop inside of a loop. And that's why this is kind of indented inside of this indent. So what I'm doing is I'm getting, 1 at a time, I'm getting my 5. And then instead of going on to my 6, when I get my 5, I'm going to do a whole bunch of steps with that 5 using my kind of inside or my second loop. We can see do all that. So I'll do 5 times 1, 5 times 2, all the way to 5 times 10. And then I end this loop, and then I come back out to the top, and then I go from 5 to 6 this time. Then once I have 6, I can do all these steps to just the 6, and then I can come back up, get my 7, and do the same things to that. These things that I added, the prints, that's just to help, space this out and make it easy to see. I'll explain what this is when we get to strings, actually. So you can kind of not pay attention to this and this. That's just to make it kind of visible on the page. So this problem it's kind of difficult. It can take a little bit to get used to kind of putting things inside things and thinking, how can you get what you want, get what else you want, and then combine them. But the point of it is just to demonstrate that you can kind of nest things within inside things in Python and combine all the code tools that we have in all kinds of ways. So that one's a bit complicated. You might need to take a look at it and practice yourself, see if you can make it again without looking at what we did today until it begins to make sense. Because Python is a new language, so it takes a while to get used to thinking in a new language, thinking kind of like mathematically, logically. It's just it takes time to get used to. Okay. So that's the end of what we'll talk about with lists today. And then I just want to mention, or do one last little bit on a slightly different topic that'll help us next time. So we'll leave behind lists for now, and we'll actually be leaving behind Python and kind of studying We're getting the basic tools to kind of a whole new language that can help us in this IDE. So what we want to take a look at is actually the shell. So we've had this shell kind of hanging out in the IDE. We didn't use it quite yet. We know what the console does. It takes all the print statements that we have and puts it in the console. We can also just put Python code itself into the console, kind of do it one by one, in kind of like a sandbox mode. But the shell is something else that we'll need to use the IDE fully. And I'll demonstrate why in a second. So as we go on, next time we'll probably make a new Python file so we don't have so many notes in this main.py file that we have. So we can actually set that up. We'll say make a new file. I'm going to call it week3.py. We need that .py to say it's a Python file. So now we just have a new blank text file, a Python text file in my thing. So let me come to it. Let me just put some basic Python code in, and then let me push play. And you can see what it's doing is this play button only runs the file in my file system called main.py. So if I have any different files, it's not going to run it. This is just kind of like a quick button to always run main.py if you have a chief file that has most of the code that you want, or if you just have one file to begin with. So once we have multiple files, this is going to become kind of obsolete to us. So that's when the shell comes in handy. So the shell is like what they call the command line. You have this on like most PCs, this kind of black box that you see. This is also a shell command prompt, console line, kind of the same thing. We have like a mini one in the Python IDE. So we need some new commands to see how to run the shell, because it doesn't take Python commands. It takes a new set of commands called shell commands. And this is the list of them. We'll go down one by one. We only need a couple. And basically what we'll be using it to do is to navigate my file system, my different Python files, and choosing which one to execute at that time. Because like we said, this button only does main.py. So if we want to run the week3.py file, we need to use the shell to do that actually. And this is what most IDEs have. If you download like VS Code or like Atom or any of the IDEs that you have as an application on a laptop, you don't have a nice easy play button. You need to use a command line command to execute the Python file that you indicate. So it's not too difficult. We'll just kind of go one by one at these commands and kind of see what they do. And then we'll just kind of begin to use them simply next time. Okay. So my ls command is an abbreviation of list. It's on this side. And it just lists the content of my file system as I'm at right now. So ls, and we can see I have my main.py. I have my week3.py, and I also have these couple files that come with my replit, which I don't need to pay attention to. So that's ls, so we can just kind of see the files that we have, and that's useful because we'll want to pick one to execute in Python. So let's go ahead and kind of use the second command. If we do Python and then choose the name of a file that we have, like this, then that's going to execute the file that I have, even if I don't have it open, even if I can't obviously see it now. Python says execute this Python file, and then week3 says choose that file out of the list that I have if I chose to see it. I don't have to use list to use Python. I just use list to see which files I have available. But we could just do this by itself if I know what we have. One last thing we need to add in so we know what's going on. Let's add a new box. And then inside of that, I'm going to add a, let's call it x.py to give it an easy name. Let me come to that, and I'll just put, let me open this up. In x.py, I'll just put, this is file x. Just so we have something so we know how to play it. Let's come back, and now we have a bunch of new stuff in my file system. So if I come back and say ls, we can see I see the box that I just made, but I don't actually see my x.py. And if I attempt to run it, we can see we get kind of like a new type of bug statement from the shell instead of the console. And it basically says can't open file, and it basically says it can't find that file. So with the command line interface with the shell, we basically need to think of it as like when we open the file system on a laptop, anytime we want to open a specific file, we need to like navigate the specific files that I have and jump inside these boxes to open the file that I need. In the same way, we need to kind of like be in the location of a specific box that we have to actually open those files. So just like I'm navigating this way, jumping out, jumping back into images, and then clicking on a file to open it. Just like that, we need to do the same thing, but just, basically the same thing, but as text. So if I do ls as list, I can see that I have this box, but I actually need to open that, and then I can see x.py, and then I can actually run x.py. So the same thing that's the equivalent of opening one of these, not that one, the same thing that we just did like that. This is going to be called cd. Hang on, I'm reconnecting. cd. Okay, let's see if I can type. Okay, yeah, cd. And then I can choose one of the locations in my file system. So this is a box or a bin in my system that has files within inside of it. So if I cd into that, and cd means it's on this side, change directory, kind of change which level that I'm at. If I come back and now do ls, we can see now I'm inside this box, and now I can see what's inside of it, which is x.py. So now I can do Python x.py, and now I can see that. And again, we can just use these same simple commands. That's basically all we need for the extent of this class. I have 2 down at the end, but we don't even need to get to those. So I can come back to ls. If I want to jump out of this box back to my main file system, I can do cd to change directory, and then to kind of go back out, kind of the back button that we would see. Again, to give a visual example, if we went into downloads, to go back out of downloads back to this PC, using the back button to jump out, we just do cd ... And then if I ls, you can see I jumped out of that, and now I'm at the top level again. And again, if I try to Python x.py, I can't do that. But now I can go back and do, main.py if I want. I can do, what do I call it, week3.py. So that's all we'll need with the shell in this class. It's just a way of navigating this file system and choosing which file to actually execute in Python. Since, again, this play button only does the main.py file by default. It's just an easy button. Main.py, you'll see the name of a lot of files online if you look into Python projects and things. It's kind of like a conventional name to give like the chief file of a whole bunch of files that make up a project. And then you would have different files with bits of code into it that kind of get used, but main.py is the main file that you would actually play to execute it. So that's why it's given to us as main.py. Okay. With the last couple minutes that we have, actually, yeah, we'll do this. Actually, we'll skip this because we won't be using it. But on this slide is basically the code you would use. Actually, I guess we'll do it. We'll go ahead and do it. So let me come into my x.py. I'm just going to set up a really basic thing. I'm going to say make a function called hello. And just do it like that. And then I'm going to come to week 3. So I have that saved in this file. And when you have Python projects or any type of coding projects, you tend not to have one file full of 10,000 lines of code. You break it down into sections in different files themselves. And then obviously you would need some way of telling week3.py to find the code in x.py to use. So you can kind of link them all to make one big project, but have the code kind of spliced into different files. So if I tried to do this, let me open this all up again. Let me come to my shell. Let me check which level I'm at. Yep, so that's fine. So let me Python week3.py. I'm trying to use my hello function, which I set up in x.py. Let me see if I can do that. So it says name hello is not defined. So that kind of makes sense, because if we just look at this file, obviously we define it. So we need a little bit of extra code to say we defined it in a different file and how to link the two of them. So to do that, we come to week3.py. Usually up at the top, just like we would have all the objects and definitions of functions up at the top, we would do something like this: from x.py info to all. And I'm just going to move this out so it's at the same level. Let's try this. Oops, let me come into the shell. Python week3.py. And oh, I think I haven't done this myself in a while. Okay, yeah. So what we can do is we can come into the top of my week3.py file, and I'm going to use hello in it, which I set up in x.py. And all I have to do is up at the top, I'm going to say from x, which means x.py. So you can see the mistake I made. You don't need to put the .py, just give the name of the file. And then the second thing is which code I want to include from that file. And this symbol just basically means get all the code, get all the functions. So this is how we can kind of download stuff from x.py into this one. We can do that with functions, and we can also do that with like objects and data that we have. If we want to have data in one file and then use it in a different file, we can do that as well. Come back down, Python week3.py, and then I get my hello function. And then I kind of did them the same, but data is also hello. So that's why we see it twice at the bottom. So now that we have the shell, and it's only a couple commands, but it'll take a little bit to get used to. We can split the notes in the files that we make in this class into different actual files. We can link them using this, and then we can use the shell to navigate the file system that we have, choose which file we want to execute, and then use it, run it using the Python command. That will be using all next class. So I'll be doing it obviously in class. So you don't need to memorize all these commands. I'll do it each time, and you can just copy me. Okay, and then we'll finish a couple of minutes ahead of time, but I just want to begin with the basics of strings, kind of what they look like and how to use them, so that we have a little jump on the next class when we really get into them. So to make things easy, I'm just going to come back into main.py, and I'm just going to use this file so I don't have to use my shell right now. Okay. So this is all about strings. We know what these look like. So my string is equal to hello. I said in week 1 that you can also use single quotes if you want. But the one thing that you can't do is something like this. And you can see Python automatically opens and closes the quotes when you type them. And that's so you don't do something like this, which is illegal and will crash the code. So you can't have something like this. But you can, kind of choose which quote to do. So that's how we can make a string. Let's set up a couple of examples. Do something like that. Last name is Dickens, and say book. Great Expectations. And now we can see what we can do with strings besides just making them and printing them out a little. So I can do something like this. I'm going to make a new string, and I can kind of use math symbols to combine two previous ones. So if I do something like this is going to make a new string, and it's just going to kind of glue back to back these two. So let's see what that looks like. And you can see it did exactly what I said, just glued them back to back. We'll probably want a space in between those, so we can just keep adding on things in the middle. We can just keep, it's called concatenating. Concatenation, just a fancy way of saying, you know, combining two strings. So I'll put a little blank white space in the middle, and then I have this new string. So that's useful to us. One thing that we can't do is we can't do, you know, obviously something like this. The plus sign is not meaning addition, again, is meaning concatenation. So we can't like do some string minus a second string, stuff like that. So we got to do something like that. What we can also do though is something like this, just, you know, just to know if you need it. We can multiply, and all that does is basically says, make the string, you know, repeat it 5 times. So we can use the multiplication symbol, though again, it's not quite, you know, math multiplication, obviously. So that's possible. One thing that I think I showed once is something called an F string. And let's take a look at what these look like. So I want to print a sentence using all of these things. So what it might look like, as we know now, it looks like this, the book, and then I would comma, put in my actual object. So it'll take the name Great Expectations. Continue to do this is by, let's see what that looks like. You can see that's how we can make you know, a complete sentence, but we can see it's got a little bit of odd spacing in it, and we had to accommodate some spacing ahead of time if we took that out, you know, stuff like that. So one thing to note with the print function now is we have some optional inputs that we can give it. So let's see, 1, 2, 3. So the sep, I did this a second ago, I think. Sep is what's separating things. So by default, each item that you have in print, it's going to space it out by a blank white space, but we can change that to anything that we want. So we can put in a new sep if we want. And in this case, I just use the pipe symbol. If you want to take out anything, you can just say it's a blank string, so nothing. And then we just get 1, 2, 3 without the default of what it usually would be with a white space in between each one. We can also do the end one. And that looks like this. If I do this one, then you can see, even though I have each of these on its own line, they did not print out on its own line. And what the end is basically what the print function adds on to the end of the whole print function. So usually it adds a new line onto the end of it. So each time I print out something, the next console statement jumps down to the bottom line. But I could say, don't do that. And then I can just have multiple print statements on different lines, but it'll still just do this by itself. So I can do that. I can, you know, put in anything I want instead. And then you can combine things that way if you want. This is how we can type a new line into the console. So this \n basically means a new line. So you can see on this side, I don't have \n. Each time I type that, it gets outputted as one, you know, actual blank new line. So that's what new /n looks like. And again, this is just some foundations to using strings. this one, the /t, that is my tab. So each time I do a \t, it's putting in like a tab like you would typically type. So if I look at this, you can see I tabbed all the way to the side, so we can do that as well. That's also a tool that we have. And then finally, let's go back to this last thing. This is all just, to kind of know about. You'll kind of see this all out in the wild, step and end, and these \n's and \t's. But let's come back to this example and see how we can type it as, not so sloppily. So we'll come in, and in this case, I'm going to do something like this. Instead of just putting a string inside, I'm going to do F and then an open string. And now what I can do is something like this. And what this is called an F string, this one that begins with an F. It can be a little f, it can be a capital F, same thing. And what it basically does is it lets you print out a single string. You can see I have just one set of quotes. And inside of it, I can put some, plain text. But then anytime I enclose something in these squiggly brackets, that's the name of an object that I have, and it'll swap out that object name with the actual value, obviously. So it's just basically a convenience tool to not do something like this and have to deal with the extra spaces and the lack of spaces like we had up above with this. Because with this, we might have to come in and deal with the sep in the end to clean it up and look like an actual, English line of text. But if we just use this, it'll come out exactly as we want. We don't need to keep opening and closing quotes. We don't need the extra commas. We can just do something like this, and it kind of makes sense, what it looks like. Okay, yeah, so that's everything we'll do. So next time, we'll begin to do things with strings and text. Obviously, up until now, we've been doing like math, and that's, pretty easy. You can add and subtract and divide and things. But with text, it's not so easy. You can see from the basics, we can kind of combine two strings if we want into a new one, but that's not obviously all that we can do. We can like find exact matches and things. So we can have a list of book titles and see if we can find Great Expectations inside of that list. We can match like trends. We can see if a piece of text, a string, is an email address. So if we have something, like this, and then we have something like this, we can set up a piece of Python code that can analyze all of these at once, just a simple line of code, and always be able to tell if it's an email address. And the hint will be that obviously they all kind of look the same. So we can set up like matching and trend matching. And we can see like maybe we want to find a piece of text that always ends in a .com. Maybe we want to find something that always has the @ symbol someplace in it. So that kind of stuff we can do with the kind of advanced string tools, finding pieces of subtext within the text and things like that. And yeah, so that's what we'll do next time. At the end, I have the couple of websites that I've been mentioning. We have Replit. W3 Schools is the good introduction to Python. This site is a good, it's a kind of like a game site. Well, it's not a game site. It has practice problems, so easy to advanced Python problems. So you can make an account and then get a whole bunch of practice problems, do them, and then see the solutions, see how different people did them to see if like they have efficient code and you didn't do it, quite so well. So if you want to practice a lot, this site is a good one to get into and begin to do. And then these last two also just have like introduction lessons to Python. That's all we'll do today. And I'll just remind you, if you want to keep practicing, we did leave those couple example problems in the middle of the handout, and they have the solutions if you want to check in between now and next class as well. Okay, so that's everything. If you have any questions, anything else, you can let me know. Else we can, I'll say goodbye until next time.